Now, with our understanding of real and reactive power, we can define a new concept called complex power. So because we have two types of power in our AC circuit, power is simply not V times R, or V times I in this circuit. We are going to define a new quantity called complex power, which is S with a hat on it. And we're going to talk about average power, which comes from resistive elements. And we're going to talk about reactive power, which comes from inductive or reactive elements. And we're going to put a J for the imaginary unit there because our complex power is going to be a complex value. And so this resistor right here is going to give rise to the average power. So this is our real power, or our average power, consumed by the resistor. And all of our reactive elements in the circuit are going to give rise to our reactive power. So Q is our reactive power, and it just has the symbol Q. P average is our average power. It is also called real power, or the power that is consumed. And then complex power is this value S. And it's S with a hat, and later we will see what just scalar S means. But complex power is this right here. And so often, because complex power is a complex value, we can plot it on the complex plane where we have our real number line, which is for our average power, and on our imaginary line here, which is B for our reactive power. And so you might analyze a system, and let's say you come up with the value 5 plus 10J as your complex power. And so your complex power would actually be at a point here in this 2D space. And the reason it's important to plot this space, and we're going to return to that concept about voltage and current phases, is that given how out of phase your two sources are, we can actually see it on this plot. So this angle here between complex power and the x-axis, this phi of z, this phase angle, is actually can be pulled from how much those voltage and current waves are out of phase. So if black is our voltage wave and blue here is our current wave, the amount of phase that these two are out, they are out of phase, is the same amount of phase here. So one way to think about it is that the more the voltage and the current are out of phase, the more reactive power there is. And that makes sense because it's all of these inductors and capacitors that make our voltage and current waves get out of phase. So the more out of phase they are, the more reactive power there is in the circuit. And ideally, we're going to want to try to put our system down here where there is no reactive elements, where it's completely all in phase and it's all completely real. But we're going to see that that's not always possible, but also discuss some ways that we can try to make our circuit be as real power and have as little reactive power as possible.